So I guess my first question is, how many of you guys have experience with SolidWorks? And so we're going to start with the very basics. So whether or not you've spent a lot of time on it or not, we're going to make sure that we start from the very beginning. And so the first thing I want to talk about is just planes. So the first thing that we're going to do is that we're going to decide where we're going to start building from. And so that's just like thinking about your model and how you want to approach it. So like if you were looking at a phone or something and you wanted to build it while it was standing up, you might choose either the right or front plane and start building from the sides, because you can easily just rotate it however you want. And it's really easy to just start building anything from the ground up. So for our little exercise, what we're going to do is I'm going to walk you guys through building of like a small house, like the kind that you have when like you're in kindergarten and you just draw your little box and you make a house just kind of out of extrusions and some revolves, just so you can kind of get an idea of what it's like. So to start off, we're going to build the size of our house. And just because that's the way I like to do it, I'm going to start with the top plane and just look down and build up. So I'm going to go to Sketch. And so Sketch is the portion of SolidWorks in which you get to draw things out, from which things will be either extruded or cut from. So I want to make the basis of my house, which for me is just going to be a square. So we get to pick different types of sketches. So for example, in this rectangle portion, I can choose whether I want to put it at two corners, put it at the center, and make different types of shapes based on what I want. So for me, I am going to pick a center rectangle. And so it's going to have me select a plane on which I want to put that rectangle on. And I'm just going to put it right in the center. As you can see in the top right, it's going to give me coordinates that will just kind of tell me exactly how big it is. But with a lot of engineering things, we want to make sure that they're really specific. So what we're going to use is you can either click on each line and slowly edit all the parameters so that you can have your square. But a good way to do it is using the Smart Dimension tool. So for example, in this functional house, we can make it as large as you want. So we could make it the size of an actual house and make it like 20 feet. But just for the sake of everything being kind of easily visible, we're going to use inches. So I'm going to say I want my one side of my house to be 6 inches, and I want the other side of my house to also be 6 inches. And so here we have our 6-inch square on the plane. And so what we're going to do with that is we're going to exit Sketch, and we have the sketch on top. Now, once we select the sketch, what we can do is make it a feature. And so there are a couple different things that we can do with that. We have extrude, revolved, extrude cuts, which we'll see later. So in this case, I just want it to get a little bit bigger. So I say, okay, we're going to do a blind. And so when you're extruding to a direction, you can choose how you want to extrude it. So blind just means you set a distance and it goes up that distance, no matter really what's in the way. But you can do things like up to vertex, up to surface, up to body, middle of the plane, and all of those are different commands. So let's say we had the roof built first, and I wanted the roof to be at a specific place so that people could look above their neighbors. And I didn't care how high the house was, but I just wanted to be able to get to that roof. I would click up to body or up to surface and select what I wanted to go to. But in this case, we don't have that, so we're just going to do a blind extrude. And I just want this to be a big square. So I'm going to say I want it 6 inches tall. So I can have this nice cube. Another thing that you can do with extrusions is drafts. So let's say that I wanted to go down to a point. I would like my roof to be smaller than the base. I can use this extruded function and by degree push it smaller and smaller to a point. Now we don't want that, so we're just going to continue with our cube. So this is our cube, and this is what SolidWorks renders. You'll get these nice shapes that you can edit specific the appearance of it, but this is generally what you'll get. And so now we're going to add on a roof. So for this roof, we're going to want it to be slightly above the house by a little bit and slightly off the edge. So what we're going to do is, when you're thinking about SolidWorks, a lot of times it's not easy to just make a shape however you want and complete it. So for example, a triangle, there's no function specifically that you can draw a triangle and it'll have that slope of just one side. And so what you have to think about is where would this shape come from? So for me, when I'm thinking about making this triangular rooftop of the house, I think, well, I can do a couple of things. So let's say I wanted to make just a front facing with two sides going down the side. That means that I want a triangle that is what I'm looking at from this angle. So what I'm going to do is I'm going to create a reference geometry. So these are all different things that you can use to kind of have reference to what you're making. So a plane being like, I want this plane to be on the front of the house. And so you can have different things. You can have them parallel, perpendicular. So in this case, I want to make it coincident with to like touch the actual face of the house. And so I've made a plane that is exactly with this cube that's exactly like touching the cube and just extends the face that you have wider. So we're gonna make that bigger, and we're just gonna make it a lot bigger. And the thing is that you can also name things in SolidWorks. So for example, this right here, let's say I want to rename this item, and I want to say this is the front door plane, or it's the front of the house. And this middle piece is going to be the base of the house. And I'm going to continue saying that this was an extrude, so base extrude. And you could tell from the little insignia to the side exactly what it is, but this would help a little bit with just people reading down, what did you do? I did an extrude, I did a loft, I did a cut. And so with this front door plane, what we're going to do is we're going to make that triangle. And so what you can do is with a lot of not complex shapes, but shapes that have a lot of angles, you can just draw them out specifically with a line. So it's once again asking that I select a plane to draw on. I'm going to draw on the front of this plane, and I want it at the midpoint of our cube. And so as you can see, SolidWorks helps you a lot with just general knowing where the midpoints are on things, edges. As you can see here, it realized that I would like to draw onto the cube that I've already made, even though they're not technically built on the same plane. And I can extend it. And as you can see, as I go over here, right now it's whatever I want. But as I get lower, that dotted line shows me exactly how much that I'm parallel with this edge. And so I can make that triangle exactly how I want it. And we can go back to using the smart dimension. So for example, our house is 6 inches tall. So I want the roof to be half that height. So I say I want a 3-inch roof. And let's say that I only want the level to go out an inch. So I say from this point to this point, I think that's too long. I want an inch. And so it'll fix it for me. And what I'm doing with these dimensions is I'm making driven dimensions. I'm saying that the object needs to change to fit these dimensions. If I were to make this whole line of thing, it would give me an error and say that I have a driving dimension in that area that I have set. And I either have to leave this as just a number that shows up, which is a driven dimension, that it's being driven by something else, or I have to make it the driving dimension, and that other dimension will change, will become driven. And whatever I do with this size will change the other one. So I'm going to cancel because I want that 1 inch at large. So now that I've made this triangle, I'm going to make another extrude. So let's say I want only a 1/4 inch little bevel on the side of my house. So I have this. This is exactly how far I want it to go off my house. But what about the rest of it? So you can select extrusions in multiple directions. And so you can have one with a blind direction and one going to something else. And so what we can do here is that we have this 6-inch extrusion, which has just become the kind of like a default. It wonders if we want that. So I'm going to make it 625 so I can have that bevel on both sides. And so I complete it. And here we have half the house. And so one of the things that we could do is that we can make another exact one on that same line and split the house across. But instead, what we can do is mirror it. So some of the things that we have as options are these linear patterns. And for example, so let's say I was making cookie cutter houses, like in a neighborhood, and I just wanted to make a whole bunch of these houses. What I could do is make a linear pattern that's going straight off, parallel with the this plane that runs straight through the house. I think that's the right plane. No, through the front plane, and just have houses going all the way down the line. Or maybe I was making a cul-de-sac and I wanted to make it circular. I could put a point on SolidWorks and have a circular pattern around that point. So I can make a bunch of houses that are cookie cutter exactly around the same. But for this one, we're going to use mirror, which is really helpful when you want to make things exactly the same and you don't want to go through the whole process of just drawing it all again. And so we're going to do mirror. And we've selected the front plane, which is directly down the middle here. And what we can also do is just faces. So for example, let's say this, I don't want it along that plane. I would like it along that face. So it's just going to reflect itself along that face. And I'm going to mirror this. And now I have my little house. So is everyone with me so far? Awesome. So now we're going to go to extrudes. And so extrudes, oh no, sorry, or extruded cuts. So here, these extrudes, they're creating material. Now, I would like a small indent for a door in the front of my front plane. So one thing that you can do is make an extruded cut. And so what that is essentially you saying, I would like this to go through it all. And so we're going to make our sketch. And one of the things that you can do is that you don't have to sketch on planes. You can sketch directly on any face that you have from an extrusion. So I want a little door. I'll do a 3.1. Actually, I'll do a 3.1. No, what is that? So here's my door. So I'm going to make it 2 inches tall. So what I can do is, for example, set the smart dimensions so that each of these is exactly the same. So I want this door to be 0.5. Ooh, what was that? Oh, that's not what I wanted. I'm gonna delete that. Okay, so I clicked something else down here on the midpoint, but the door looks fine. So what we're gonna do is you can add different shapes. So for example, this arc here, I want a little arc on my door. And so what we can do is place that and then just kind of pick the radius of the arc. And so here, as you can see, there is kind of this gap where this is drawn on and this is highlighted. So right now, what it's saying is that this is a closed area and it wants to either extrude or cut in this shaded area. So you can do is like trim entities, cut off the top, and you see how it joins in. That is saying that now it has the whole area and that's how it wants to cut. Now, that doesn't have to be the case. For example, if I cut this in half and I want to make the extruded cut, I can choose which sections I'd like to cut. And so this one and this one, and I want it to be in the same amount as that bevel. So now here we have a small indent, and that's what the cut does. It takes anything in that area and cuts it through. Now let's say I want a window that goes straight through the side of my house, a big window. And so I might as well save this. So let's say I want to have a big window and I want it to be some interesting shape. So I'm going to use a spline. So I want this weird kind of shaped window because I would like that through my house for some reason. When I make this extruded cut, this is when I can select things like up to next. So that just goes up to the next phase. And that's going to do the same thing as up to surface. I have to select a surface, so I could select this. I can do through all, which will just go a little bit farther than whatever is closest. And then through all both would mean that it would go through both in both directions. So we're just going to go up to next. That seems the simplest. Select, and this is my window. So another thing we can do, for example, is we want to take this base extrude, and I want it to be walls rather than a thick base. One of the things I can do is make it a shell. And so I want this to have a thickness this is a multi-thickness setting. So first we can do show preview. And what you're going to see is that there's a small shell around all of this. So we're going to hit check. Oh, it didn't work. I have to select them. Oop. That's weird. Okay, so actually it is currently a shell now. And what we have is these inside borders. But that's a thing to make things hollow. So, for example, if we did a section view, you can see that it's hollow now. And so that's another nifty trick, actually, for viewing how your parts are going. So this section view allows you to check and make sure that every single portion of your house is looking how it's supposed to. We're going to exit out of that. Okay. So these are kind of the general ideas of what kind of cuts that we have. So another major thing is revolution. So that's you picking a center point and having it revolve around that portion. So for example, I want to make a chimney. And so I'm going to make it in probably one of the most excessive ways, but for a learning purpose. So I'm going to take another reference, another plane. I'm going to put it here. I don't want that. Just going to go ahead and make this the first reference. And I just want it right. Okay, well, a certain distance above. So we know that the house is 6 inches tall. The roof is 6 inches tall. So at 9 inches, you have the top of the plane. So we're just going to make it a little bit higher. So 925 is where our plane's going to be. And I would like a circular chimney. So what I'm going to do is we're going to go here, sketch onto this second plane. And make a little pizza slice. Actually, we'll just, I don't know how well this will look, but, and for some reason, I want this to have a revolved base. I guess that would be a revolve. Oh. Never mind, guys. I'm gonna do something else. So we're gonna make that same plane just based on this right plane here. That's already in the middle of the house. And so I want to make a chimney. I'm gonna make it off the right plane. Perfect. Just here, parallel. we're going to have it go into the house a little bit. And so I want this to be circular. So what I'm going to do is I'm going to do a revolved base. And I say I want it 360 degrees about this axis. And this is going to be my pretty terrible looking chimney. That's generally how revolutions work. It mimics whatever you have around it and creates a circular piece. So something interesting to note is that we have a shell and then we have this solid piece that we created. And so when you look inside this house, it will make this solid piece, regardless of the shell that you already have in place. And so that's our little chimney. And the same thing works for cuts in the same exact way. That area that would have become something if we selected extruded cut, would just cut around it. We just cut that same piece. So here is our little tiny house. Another thing that we can do is when we're trying to make our designs symmetrical, what's a great tool that we can use is this center line. So let's say I want to make two equidistant windows. So I'm going to make, while we could use the mirror setting and draw them on one, I'm going to show you a different way to do it. So here I've made a small line, and now I have the midpoint there. And I want to go to that midpoint, straight down, and find my second midpoint. So now I have these two midpoints, and I can start making my windows. So at the center point, I want to make it at the wood point, and I want them to be, sure, 0.85 by 0.85. And an easy way to do it would be to do that mirroring that we were doing earlier, and just have it flip across this center line that we have in the house already, just simply because we made it on the midpoint. But let's say that I didn't have that center line, and there was, I wanted to make something similar, but a little bit more different and have that same kind of structure to it. I just do the same thing on the other side, and I'll get the same point. So between these two, center line, mid center line again. There we go. And we can have it in the same exact place. And as you can see here, it is already creating connections to try to make it symmetrical. So we'll do the same thing again, where we smart dimension the height. That it doesn't want a smart dimension. Okay, 0.85. And so we can do that. And the same thing works if we wanna make cuts. Well, extruded cuts, we can select both those and have it go through 0.35. So what's kind of cool is that we can actually see inside the house now, and see inside that shell, and see the weird hollow thing we made in the middle. So let's say that I want to make it super complicated, and I want to fill the inside with furniture and a bunch of CAD drawings, a bunch of CAD things that are super intricate. And I want a garage, and I want that part to be super intricate. And so I'm going to leave a portion of my house that has an area for a garage. So I'm going to use this 3-point corner rectangle again, and I'm going to draw on this face. Is it actually on the correct face? No, it's not. So there, exit sketch, clicked on that again, create a sketch. I want to do a little portion for a garage. So I'm just going to put it here, like this, I want to make it a little bigger. So I'm going to use that smart dimension again. Make it half of it, 3 inches. We're going to have that here. And we're just going to do a little extrusion. That's fine with me. This is where I want my garage to go. I want eventually to have a little garage for a motorcycle or something, and I want to put it there. And I want to make it separate. So I've already saved this, and so I'm going to make a separate file. So new part. And I'm going to open it up. And what I like to do, I personally like to have my planes open. I think they really help me orient myself and kind of give me an idea of exactly what I'm looking at. So like I said last time, we can choose from where we start from. So this one, I have 1 dimension. I have, well, I should get multiple. So we have the 3-inch bottom and the how tall side. Actually, let's just make it 3 inches as well. We have our 3-inch little square. And so I know that now. And I'm going to go to my second part, and I'm going to save it as, this is going to be my garage. And I want to start on this front plane because I know exactly how big I want this garage. So we're going to get center rectangle. We're going to say, actually, maybe we'll do this 3-point rectangle. I want in this one from the center to here to here. Smart dimension it 3 inches by 3 inches. This is the size of my garage. And so have that there. How big do I want it? Extrude, I want it 3 inches. I want another cube sticking out of my house. And so I have this here. And I can choose, I want it in the other direction. And just because that works spatially for me, that's what I'm going to do. And so I want a funky looking roof. So I'm going to use that revolution again. So we're going to, once again, make a plane, reference treat plane from here. But I would like the offset flipped, and I want it in the middle. So 1.5 inches from the plane. I want it straight down the middle. Cool. Make it a little bigger. Make it a little bigger. I want a circular roof because yes. So I'm going to go towards, once again, I'm going to use that midline principle. So I don't know exactly where the midpoint on is, and it might not tell me. So I can go center line onto this center line, and it will tell me. Or not. Sketch. Okay. Try again. Center line. From here to here is my center line. And so I just have that portion right here. And I don't have to use it ever. I can exit sketch, leave it there, have my center line there. So when I am making something on my plane and I would like it in the center, I can use that center line or just bring it to the middle. I know exactly where we're going. So go up a little bit, down here. I'm gonna extend it a little bit. And so we're gonna do a smart dimension, bring that down to 1.5. And we're going to do that revolution. So revolve. Put my axis down the middle, have my little pagoda top. And so this is my garage. It's ugly, but it works. So I'm going to save it. And now I want to I want to connect it to my house. And so what that means is that I'm going to make an assembly. And so an assembly is when you take multiple parts and you can put them together. And so one of the cool things you can do with that is, let's say, is workshop. Okay, I would like it to be saved. I'm going to I can open it up directly from here, or what I can do instead, file, make assembly from part. So what I can do, begin that assembly, get my house in, insert another component, insert the garage. Oh, okay. So one of the things is that if you insert automatically, what's going to happen is that it's just going to lock it to the center of whatever you brought it in. So if you want to insert a component, garage, this lets you place it wherever you want. So in this case, I don't have a garage on my door. So I don't have a door on my garage. So what I'm going to do is I'm going to start mating things. So mate, doesn't really matter where I put it. I want this face to be mated with this face. And I'm going to switch. And so sometimes things get a little weird. So we can break that. And I'm going to try a different way to do that. So I want this side and this side to mate. Correct. I'd like this bottom one and this bottom one to mate. And I would like this and this to mate. Oh, coincident. So now I have my mates. I have my garage placed on its portion. And so this is really helpful when you have complex systems. For example, if I were making like something for the surgical team or something for the MRI, and I have a bunch of parts and I want to know where goes where, will things overlap? And I can notice things like this. Like, first, the revolution was a bad idea because it looks bad, but also it would intersect my house. And so that's the thing you can notice during your portion, like during this portion of mates. Oh, it seems like I have a mate that got broken. So I'll just delete him. And so I can go back and fix things. So for example, I still have garage open. So let's say I'm like, ooh, that was a bad idea. Let's edit that sketch. I need to move this in a little bit. And you can definitely do that. Make it a little bit smaller, keep it there, save it. And on this assembly, it says, hey, some of your parts just changed. You want to rebuild the assembly? And you go, yeah. And now my thing still looks ugly, but it no longer intersects with my house. And so this is one of the cool things that SolidWorks lets you do, is just kind of put pieces together and make sure that they fit. So now, let's say that we're in the future and you can 3D print your houses, or like machine them, for example. So let's say someone would like take a massive drill and drill out your house out of the ground, and this would be inside the ground. One of the things is that they most likely wouldn't use this 3D image per se. What they would use is a drawing. And so that can say like, oh, that means I need to cut this far down the house, this far to the side. And you can send those as like PDFs and make it super simple for them. So one of those things you can do is you're going to make a drawing from the part. And so it gives you all these different things. So let's say like this is what it looks like from the top. And you can show you like different ways to bring it from. So this is the front. This is an isometric view. And so normally you wouldn't put these like as close together as I have because that's just confusing. And you'd make these look all nice and stuff. And this lets people really see exactly what they're working with. And so this is actually, I am used to 2017. I haven't done this in a while, but okay, here we go. So smart dimensions. You can start telling people exactly how big your house is, like how long everything is cut, exactly what material to make things. And with these little numbers, you can start signifying how close of a tolerance you want. You can say, I want my house down to the millimeter. I need this to be precise. You can take off some decimal points and be like, I just need it to be like around 6 feet. Like as long as it's in the area, I won't really be offended by that. And that's this where these sketches become really important. Like here you can see like welding symbol, like where to add specific welds, different surface finishes, tolerancing. And these all help whoever's making your part be able to not only see what you're doing, but have a real deeper understanding on how it's done. And so one of the cool things is like this section view. That is the middle of the house. And so this is just a cool way of just making sure you can show people exactly what they're making. And so eventually when you're annotating it, you'll say exactly like how far each specific point is, and we'll go through every point of the house and say this is that, and like this will have a, a finish or a specific curve and at each point, and we can definitely go over that at another point. But I wanted to show you guys something really cool. So we can make all these ourselves and have these really weird houses and have a whole bunch of different kind of equipment, but a lot of times you can find CAD that's already been made online and kind of make your life a little bit easier. Someone's already probably thought exactly like what goes into each portion, so you just want to like piggyback a little bit off their work. And so there's something called Tinkercad, or sorry, Thingiverse. So Thingiverse is this big database of a bunch of different CAD that people have made from all over the world. And like Andrew can tell you, Grip uses this heavily to get its prosthetics and give out some prosthetics to the rest of the world. So like here, you can have a kit to build a AT-AT, or you can have a small 3D printed a globe thing. You can have stuff for your phones. I don't even know what that is, but for your garage, let's say you just want a car and you just want to import it. You don't really want to make something that crazy. So you say, I want to import a Ferrari. And so you can go to Thingiverse here and just pick whatever car you want. And so let's go here. I like this one. I don't know. And it's got free file. So as you can see, you got a wheel, you got the complete thing, and you got the body. And I want the complete thing. So I'm gonna download it. And I'm gonna get this. And so one of the things that you'll need to notice is that when you are looking at when you're looking at your files, things you make in SolidWorks appear differently from things that weren't made in SolidWorks. So things that are made in Creo can't be opened by SolidWorks and vice versa. So one of those ways to convert files is to make them an STL, which is what we got here. So this is an STL. And so one of the things is that, like, for example, right now, I don't need SolidWorks to open it. And it looks a little weird and the controls are a little different, but this is the car as an STL. And so STLs are just a bunch of triangles and math and things that let you take CAD files and convert them into something that can be read by any CAD software. So let's say I wanted this in my house, or I just wanted to take a look at it in SolidWorks. So I'm going to close this out. I don't particularly need it. I want to open something new. And I want STLs. Let's see if I can find STL. Ooh, I am blind. So, but like, as you can see here, Rhino, where is STL at? Oh, here it is, mesh files. There we go. So now we get our file and we get it in SolidWorks. And so there are multiple ways. So this one came in as a graphic, which I've never actually seen before. But usually what that means is that they have some real complex shapes, and that SolidWorks really, when you looked at it, said, honestly, I have no clue how they made that. I'm not even going to try. But if you have something simple, like a square, SolidWorks will make guesses. SolidWorks will say, like, I think that this was an extrusion across the whole thing. If they made another extrusion, another cut, and give you kind of like a guesstimation as to how they made that. But in this case, this is very artsy design. They probably made it in Mesh Mixer, and it has a lot of curves and fancy looking, like, that's a lot of detail. Like, it even have like a cool looking windshield wiper and whatever. So it just has it as this graphic. And so, which closed means that you can't really edit it. And normally you wouldn't be able to edit things from an STL. And so what you can do is you can still import that into your assemblies and be able to look at them. Another cool thing is that when you're making parts, I really like using McMaster. And so the reason I like using McMaster is, for example, let's say I am making an assembly for the MRI team, and I need to make some bolts, put some bolts together to screw everything together. And I don't really know what size nut to use for these screws. I don't know if while twisting they'll bump into things. I just really want to make sure. Like, I just want to make it 100% sure that I'm not messing up. I'm not going to order a bunch of the wrong size nuts. So what you can do is you can go to each specific point and go to that product detail, and you can download these parts. So this nut, I can download it as a PDF, as an IGES file, which is also pretty popular. And I know that a lot of 3D printing companies will actually ask you to send their files in that, because you can up how much, like, the how much information is in each file, so you can make them like really accurate. But we're going to use SolidWorks. So I'm going to take SolidWorks, I'm going to hit save, and we're going to open it up. So I'm going to close out of some of these things just for some space. Or not. Oop, did it just crash? No. Okay. So file, open, steel hex nut. And so, um, here, what you can see is the exact nut that you wanted, and you can see exactly how they made it. And so that's something that you can do that's really cool to look at, is that if you want to know how an extrusion is built, you can do this. And you can look through each portion and see exactly how it's built. And one of the cool ways to do that is to backtrack something. So for example, I want to see how this helix is made. I can go to when it was just a square, look at the helix, see exactly like how it was made, see what kind of dimensions they have, and just go back and move through and see every single point on what they did. And so that's a really good way to learn SolidWorks, is just to be able to go through and see exactly what it takes to make all these different types of shapes and dimensions. So do you guys have any questions? Awesome. Well, it's a little bit early, and that's our SolidWorks workshop. So thank you guys for tuning in. I'll be sure to put it on YouTube, and you can say if any of your other teammates has any problem with SolidWorks, they can either come to me or come to this video. So thanks so much, guys. I'm gonna stop recording.